This is a continuation of the test number 1 review questions. This video will cover questions 11 through 13. So let's get started. Question number 11 involves an inequality that you're asked to solve. And I think of this as a kind of a between, because you have a negative 8 is less than 4x plus 2 over 6, which is less than or equal to 3. So you have kind of a problem on the front end as well as a problem on the back end, but we can do it all at one time. And the first thing that I would like to do is get rid of the fraction or the multiplication by 6. And so to do that, I'm going to multiply the entire equation by 6, and I'm going to write that out. So I'd have 6 times negative 8 is less than 4x plus 2 over 6 times 6 over 1 is less than or equal to 3 times 6. And if I come back and do those multiplications, I have 6 times negative 8 is negative 48 is less than 4x plus 2 over 6, and the times 6, the 6's will divide out, and I'm left with 4x plus 2, which is less than or equal to 18. Again, the goal is to get the x by itself, so I need to subtract 2, and I'm going to do that to the front end as well as the back end. So I have negative 50 is less than 4x, which is less than or equal to 16. I then need to divide everything by 4. So I have negative 50 divided by 4, 4x divided by 4, and 16 divided by 4. So I have negative 50/4 is less than x, which is less than or equal to positive 4. Negative 50 over 4 is a fraction, but it'll simplify to negative 25 over 2, which is less than x, less than or equal to 4. Now remember what these symbols mean. Less than or equal to means you can include or use the value of 4. You're asked to write the answer in interval notation, and it may help you to think about what it would look like on a number line first. So if you have a number line with 0 in the middle, obviously positive 4 would be to the right, and somewhere on the left you would have negative 25 over 2. Well, the difference is, can you use or include the point or not? Well, negative 25 over 2 is a less than, so it's not used. So we use a big old hole or a circle, open circle, at negative 25 over 2. At positive 4, though, it's less than or equal, so I can include it. So I can shade the dot in to show that I can actually use that point and include it. And then we have any value in between. And we can translate that to interval notation. When the point is not included, we use a parenthesis. So we have parenthesis, my beginning point is negative 25 over 2, comma, my ending point is 4, and I can use it. And when you can use it, you use a bracket. So in interval notation, you have open, negative 25 over 2, comma 4, closed. All right, moving on to number 12. Number 12 asks you to solve an equation, and this particular equation is a quadratic. And again, I recognize it as a quadratic because it has that exponent of 2. Typically with a quadratic, we can either factor or we can use the quadratic formula. In either case, whether we want to factor or use the quadratic formula, the equation itself has to be in the form ax squared plus bx plus c equal to 0. In other words, it has to be equal to 0. So the first thing I'm going to do here is get the equation set equal to 0. So I'm going to add 6x and minus 3, or add 3 to both sides at the same time, doing 2 steps at once, so that I have x squared plus 6x plus 3 equals 0. If I think about factoring, I don't believe this particular problem will factor. So my alternative, or my best alternative, is to use the quadratic formula, which, if you don't recall, is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Remember, a is the coefficient in front of the square term, which in this case is an understood 1. B is the coefficient in front of the x, or the linear term, and c is the constant. So I'm going to do those substitutions. I'm going to plug those values into the quadratic formula so that I have x equals opposite of 6 plus or minus the square root of 6 squared minus 4 times 1 times 3 all over 2 times 1. Doing the math, negative 6 plus or minus the square root. 6 squared is 36, minus 4 times 1 times 3 is 12, all over 2 times 1. So I have negative 6 plus or minus the square root of 24, 36 minus 12, over 2. I then need to simplify the radical. So I have negative 6 plus or minus 2 on the square root of 6, all over 2. I then notice that I have a common factor of 2 in the numerator, so I'm going to take it out. So I have negative 3 plus or minus the square root of 6 all over 2. And then since I have a 2 in both the numerator and the denominator, they will divide out, and we're left with negative 3 plus or minus the square root of 6. All right, number 13 says add and simplify. And we have a rational expression added to a rational expression. In order to add rational expressions, we have to have a common denominator, which I do not have at the moment. So that's the first thing that I have to do before I can work the problem, is determine what that common denominator could be. X plus 5 is as simple as I can get it. So that's going to have to be in the denominator. X squared plus 6x plus 5, I believe, will factor. So I can get a sense of what pieces I need. It factors into x plus 5, x plus 1. So if I look at my problem, my first rational expression is x over x plus 5. My second one is 3x plus 4 over x plus 5, x plus 1. So in order to have a common denominator, I need to have both x plus 5 as well as x plus 1 in the denominator. So I need to add an x plus 1 in the denominator of the first fraction. But if I add that to the denominator, I also have to add it to the numerator. So in a sense, I'm multiplying by 1. So now, by doing that, I have a common denominator. Once you have the common denominator, you can actually add the numerators together. We keep the common denominator, and we add the numerators together. Now, before I add them, I'm going to go ahead and multiply this thing out. So I have x times x is x squared. 1 times x is x. I have plus 3x plus 4. And then I can come back and I can put together the common pieces, or the like terms. So I have x squared plus 1x plus 3x is 4x plus 4 over x plus 5 times x plus 1. Now, I'd also ask us to simplify, so we need to make sure that this fraction doesn't simplify anymore. Could it be broken down any further? And to do that, we need to factor the numerator, which does factor into x plus 2 times x plus 2. Well, I don't have any values in common in the numerator and the denominator, so ultimately, in its most simplified form, I have x plus 2 squared over x plus 5 over x plus 1. Now, honestly, from my perspective, in terms of the math, this answer in red is an acceptable answer, or this final answer in purple is acceptable. You need to be aware they're both acceptable because it is multiple choice, and so it might be written one of those two ways. I want to do one other problem that wasn't really on your review sheet, but I know is on test number 1, and it has to do with complex numbers and multiplying them together. You have basically a two-term expression times a two-term expression, and so to multiply those together, we can use full. First, outside, inside, last. So if I do that, 3 times 2 is 6. 3 times minus 5i is minus 15i. 2i times 2 is plus 4i. 2i times minus 5i is minus 10i squared. Now, we do definitely need to go back and combine the like terms. So I have 6 minus 15 plus 4 is minus 11i minus, let me fix that, minus negative or minus 10i squared. But guys, with complex numbers, you should never stop or end a problem with an exponent on the I, because by definition, I squared represents a real number on the number line is equal to -1. So that's kind of one of those things in math that you need to know or memorize. So I'm going to replace I squared with -1. So I have 6 minus 11i plus 10. -10 times -1 is positive. And so then when I combine like terms, I have 16 minus 11i. And typically when you write a complex number, you're going to write the real part first plus or minus the imaginary part. So that's why it's written in this particular manner. Okay, so again, you'll see something like that on your first test, so I wanted to add it to the explanations.